In the 2024 Chemistry O-Level Practical Exam, we had 3 experiments. We had an acid-base titration. The second experiment was a gas collection by displacement of water, and then the last one was a qualitative analysis. The first experiment is an acid-base titration using thymothalin indicator. So after 2 years of absence, after 2 years of being caught a scammer by my students for having prepared them for titration and titration didn't appear in their exams, finally this year titration has reappeared. In fact, acid-base titration using thymothalin indicator was tested before in 2020, and if you had managed to dig out some of the UK O-Level practical papers, this practical task, including the questions that came after, are actually very identical to the 2012 UK O-Level practical exam. So I believe with all that practice that you had before the exams, many if not all of y'all would have become experts at carrying out the titration accurately. The titer value that we got was 23.00. Now don't be overly anxious if your titer value is different, because at different exam centers, I believe the solutions may have been prepared slightly differently. So the titer values that your teachers may have gotten would be slightly different as well. However, the calculation steps are pretty routine. As usual, we can make use of the 3C approach to find the answer. So the first C is to convert to moles, is to convert the titer value, the volume of NaOH, to moles by multiplying by the concentration given. Next C is to compare mole ratio. So the ratio of acid to sodium hydroxide is 1:2. So the number of moles of acid will be half that of your sodium hydroxide. Next, the question tells you to find the number of moles of your acid in 1 dm³ of solution. So all we need to do is to scale up, or to take 1000 over 25 times number of moles of acid that we have found previously. And from there, we can multiply it by the molar mass to find mass of acid. And given the mass of your hydrated acid that was used, we can take the mass of the hydrated acid minus the mass that we have just found to find the mass of water present, or the mass of water of crystallization, after which we can find number of moles of water, and to find the ratio, we just take the number of moles of water divided by the number of moles of your anhydrous acid. In this case, if you had used the titer value of 23, you would have gotten a value that's very close to 2. And importantly, when we are looking at the number of water of crystallization, it's usually a whole number. In fact, the question states that it is a whole number, so you need to round your final value of x to a whole number. For C part 1 and part 2 is to test you on the understanding of titration. So C part 1 talks about rinsing of the conical flask and having some water remaining in there. Is it going to affect the titer value? The answer is no. There's no effect, because the titer value depends on the number of moles of acid present, or the number of moles of acid pipetted into the conical flask, and having water in there does not change the number of moles of acid present. That is also the reason why when we wash the conical flask in the midst of the titration, nearing the end point, it is not going to affect your titer value. For C part 2, the question is talking about this scenario where a student consistently got the higher titer value, and why is it not going to affect the whole number that's calculated for X. Honestly, for that, I am not 100% sure of the answer, but based on what I think, is that if we look at the concentration of NaOH is actually very low, 0.075 if I don't remember wrongly. So when you have a change in the titer value, it's not going to lead to a very big change in the number of moles of sodium hydroxide. So that is reason number one. Reason number two is that for when we obtain the value of x, we have to round off to the nearest whole number. Hence, there's a range of numbers, or there's a range of decimals that for which we will round off to the same whole number. So that, I believe, are the two reasons. Number one, the low concentrations of your sodium hydroxide. So when your titer value is off, it wouldn't affect the calculated number of moles by a lot, and also that the final value of x is rounded off, so the range of values that would give you the same answer is quite large. For question number 2, we are looking at gas collection using displacement of water method. That would come as a surprise for many, I believe, because many schools, including ourselves, we wouldn't have the necessary equipment for everyone to do this experiment. So it's unlikely that students would have practiced this before. Nonetheless, I think the procedure was detailed enough. The procedure was very guided such that students would be able to do this even if you are doing it for the first time. So the actual task required students to add a magnesium strip into a diluted sample of acid, and then to record and to measure and record the volume of hydrogen gas collected or produced and collected using water displacement. So it was pretty simple. All students had to do was to read the final reading on the measuring cylinder after no more gas has been produced. The important thing to remember is that in the procedure, we were actually starting the initial reading of your measuring cylinder was set at 10. So students were required to introduce air into the measuring cylinder until the initial reading is at 10. So in order to measure the volume of gas produced, we need to take the final reading minus the initial reading of 10. So in this case, we got a volume of roughly 50 centimeter cube. Again, we would expect different students to get slightly varying volumes, because despite the magnesium strips being cut to the same length, roughly the same length, there is bound to be some variations in the actual mass of your magnesium for individual students used. So I believe there will be a range of values centered around 50 centimeter cube. For part 2, students were supposed to identify which reagent is limiting. This is quite obvious. After the reaction, there's no trace of solid remaining, no metal remaining, so therefore your magnesium must have been limiting. The next part of question 2 requires you to plot a graph. This again is nothing new. If you have practiced the past year papers, plotting of graph is a common feature in your O-level exam. So after plotting of graph, students were required to draw a curve of best fit, and then from there to obtain the average rate over 25 seconds. So again, if we were to look at the 2020 paper, this is a similar task. All you needed to do was to record the volume of gas, or from the graph to find the volume of gas at 25 seconds, and that would be roughly around 57. So 57 centimeter cube. So the average rate would be 57 divided by 25. One thing to take note is that the question requires you to leave your final answer to 3SF. So it is 2.28 centimeter cube per second. Next, the question requires you to describe how the rate of reaction changes. So as the reaction proceeds, the rate of reaction actually decreases and eventually reaches 0 at around 80 seconds. So how do we tell that from the graph? From a volume of gas time graph, the rate of reaction is indicated by the tangent, by the gradient of the tangent at the different points. So from the graph, you can see that the gradient or the slope decreases and eventually reaching 0. Part 4, students were required to draw another curve in a scenario where the concentration of your acid was reduced from 0.5 to 0.25. So the concentration of acid was decreased. I think this is a heavily practiced theory question, but unfortunately also I've gotten reports from students where they have missed out this question totally. So the graph is quite easy to draw. You just need to draw a graph of a less steep gradient, and then the question also says that it reaches the reaction is finished by 90 seconds, so the curve should level off at 90 seconds. For part C, we are looking at the third experiment of qualitative analysis. The question gives you two acids. The question states that you are given two acids of different anions. So I think the slightly tricky or intimidating thing about this part is that the procedure for 1 and 2, test 1 and 2 is not given. And you are given the flexibility of deciding what test to do. And students in an exam, they are used to having the procedure given to them. So when you are given the flexibility, some students do get thrown off by it. So, but actually it's not that difficult. Reason being, the test procedure for test number 3 is already given. It's obviously a test for nitrate, right? You had to design two other tests. The question states that the anion is in your QA table. So all you needed to do was to go back to the QA table at the very last page, and then from there decide on which test to do. And the two obvious tests that you should be doing will be the test for your chloride or iodide and the test for sulfate. So as described, the first test that we did was to add an equal volume of nitric acid followed by 1 cm depth of silver nitrate. That is the test for chloride or iodide. And D gave a white PPT, F no observable change. That immediately could tell us that chloride is present in D. For the second test, where we added an equal volume of nitric acid followed by 1 cm depth of barium nitrate, there was no observable change for both D and F. That would tell us that sulfate ions are absent for both. Alright, and for the last test that was given in the instructions, we added sodium hydroxide followed by aluminum foil and heating. For F, there was effervescence and the gas turned your moist red litmus paper blue. There's an indication that your nitrate is present. Okay, for D, if you have conducted the test, you will find that there's effervescence as well. This is not unexpected because we are using an acid, and even though we have added sodium hydroxide, there's still acid present, and when you add aluminum foil, it's going to react with the acid to give hydrogen gas. Okay, however, in my opinion, there's really no need to test for hydrogen gas here, because from the procedure, if you figure out what we are testing for, we are actually testing for the presence of nitrate, which will lead to the formation of ammonia gas. So by right, you should be testing the gas with red litmus paper. And in this case, there's no change to the color of your red litmus paper, which indicates that ammonia wasn't produced, which also indicated that nitric acid or nitrate ions are not present in D. So with that, we can conclude that D is hydrochloric acid and F is nitric acid. And note that the question required you to write the formula of D and F rather than the name. For the last question, it is a planning question. It's a rather guided planning question as well. The question states that there are 3 amino acids in some food powder and it dissolves in water to give a colorless solution. Now, I don't know how many of you caught it, but the colorless solution is an important phrase that's there to remind you of something. So the question also recommends using chromatography. So all you needed to do was to describe the setup for chromatography. There are a few, I think 3 main parts to that. Number 1, you have to set up the chromatography paper. So you need to draw a start line. You need to mention that it has to be drawn in pencil. And then after that, using a thin glass tube, a capillary tube. I don't think what you use to spot the mixture matters, but it has to be thin and so that we get a small spot. So we use a thin glass tube to spot a sample of the mixture, and on the same chromatography paper we also spot pure solutions of known amino acids. So that's important because in order for us to identify, we need reference to the pure samples as well. After we have prepared the chromatography paper, then we will lower it into the solvent. In this case, I would use water because the question states that the amino acids are soluble in water. Right? One thing to take note is that the solvent level must be below the start line. And then after the separation, we need to remove the paper before the water reaches the edge of your chromatogram. And then as a good practice, usually we'll draw the solvent front with a pencil as well. The last thing to be done is to analyze the chromatogram. Now note that the question states that the solution is colorless. Right? If not, we should have also learned in the syllabus in theory that amino acids are colorless, and therefore we need to apply a locating agent. Okay, I doubt that they would require you to identify what locating agent to use, but for amino acids is to spray a chemical called ninhydrin. And then after the spots become colored, then now we need to compare the distance of each spot from the start line, and spots that moved up by the same distance corresponds to the same amino acid. So then we will be able to identify the 3 amino acids with the same distances as the 3 spots in the mixture. Now the diagram shown is obviously simplified because there are many amino acids out there, so we need to spot as many as we can, and then from the resulting chromatogram we can see in the mixture the 3 spots in the mixture would correspond to which 3 pure samples or pure amino acid samples. So as always, this video serves just for education and maybe recreation purposes. Please do not ask me whether your answer would get how many marks. I wouldn't know, and again, if I know, I wouldn't tell you. So regardless of whether you feel that you have done well or not for the practical exam, I don't think you can change anything about that. So please focus your efforts on your paper 1 and 2. Focus your efforts on what you can still change. Right? All the best for your O-level chemistry exams.